Welcome to Train Signal. I'm Mel Haynes, and in this video, we're going to be looking at the encryption options that are available to you in SQL Server 2008. So what are we going to talk about? I want to give a little background on encryption. Now, conceptually, it's probably pretty straightforward, but you never want to assume, so I'm going to give you a little real simple background on that. After that, I want to spend some time talking about the SQL Server encryption hierarchy. Now, that's a topic that can get extremely theoretical and cover far more information than most people are going to use in this lifetime. But as you do further research, which you're going to have to do if you really want to dig into encryption, you will need some of this background to understand the main components, the main players in encryption. So we're going to talk about that as well as the components, some of the key components. Next, we'll get into two encryption types. We're going to focus on cell level or column encryption. Now, I'm using two different terms because depends on who you talk to, you'll get two different descriptions or two different titles. Most of the Microsoft documentation I've come across calls it cell level. Most of the stuff I've come across outside of Microsoft has been using the term column level encryption, and personally I prefer the term column level because I think it's more descriptive, so that's what we're going to use. I'm going to get into what's known as transparent data encryption, pretty cool feature that is new, the SQL Server 2008, so we'll play around with that, see it in action. And I want to give you at least a list of encryption algorithms and just kind of talk about them in relation to each other. The details of encryption algorithms is way more than you need to know or understand in order to implement a secure database environment. But you at least want to have an idea of what are all these little acronyms and what does it mean to pick one versus the other. So we'll briefly just list that. So encryption background information, and literally simple stuff. You've got data in your database that is hopefully secure because you've got a password on the system, right? You're using Windows authentication or hopefully not SQL Server authentication, but if you have to, you can do that. Or, for the most part, you want to make sure that stuff is locked down. But once someone gets past that outer shell of security, everything's open, right? Well, even with one of the security models I'm going to show you, that's still the case. But another situation is, what if your database backup files are stolen? What if the file system is compromised? What do you do now, right? You want to be able to take information that looks like this, let's assume that's a credit card number, and make it look like that so that it's not obvious, to say the least, right? Not even close to obvious what that social security number is. You can spend your lifetime trying to decipher that. Now, of course, any lock can be broken, so I don't want to give you the impression that once you've encrypted your database, you are completely impenetrable. Well, of course, there's always a thief will find a way, but for the most part, you've created a barrier that makes it a lot more difficult, and in some cases, pretty much close to impossible to gather the information from that database. When we start looking at encryption in SQL Server, it's important to have some understanding of the SQL Server encryption hierarchy. There are three levels when you're looking at the hierarchy. First of all, there's the Windows level itself, followed by the server level, SQL Server level, and then third, the database level. But here, let's look at a diagram that'll hopefully help with that. Starting with the Windows operating system level itself, Windows provides an API, Application Programming Interface, that actually protects all the encryption that happens within SQL Server. It's the highest level of the hierarchy, and it's used to actually encrypt and protect the next level, which is known as the Service Master Key level, or the SMK. The SMK level, or the Service Master Key level, which is protected by Windows, is used to protect the next level, which is actually the database level. At the database level, we see a myriad of options. The database level actually contains your database master key, or the DMK, and the remaining keys and certificates that are used to encrypt and protect your data. Looking at the central portion of this diagram, notice I have a couple of dashed lines or dashed paths leading to my encrypted data. Those are the two options available when you're looking at TDE, or transparent data encryption. When you're looking at TDE, Transparent Data Encryption, your choices are to use a DMK password, a database master key, which then uses a certificate, a symmetric key, to finally encrypt the data. Another option is to use extensible key management. Now, this diagram shows me a myriad of paths, like I said, to get to encrypted data. We could go the route of a password to create a certificate, to create a symmetric key to encrypt data, passwords directly to encrypt data, passwords to create asymmetric keys. And we'll define some of those terms in more detail going forward. But my point for now is lots of different ways to encrypt your data depending on what your needs are. Explaining all of these different paths and all of these different options would be beyond the scope of what we want to do in this course. What I want to do in this course is focus on primarily two paths, two choices. So I'm going to make your life simple, hopefully. What I want to focus on is, one, what does it take to encrypt a column of data in my database? Right? That's a pretty simple, straightforward solution to a lot of business problems. So for example, you've got social security numbers or credit cards in your database. You want that information to reside in the database in encrypted format. So if anyone who even has rights to view the data pulls up that information, all they see is the encrypted information unless they have a key or certificate that allows them to see it unencrypted, right? That's option one. Option two, the other thing I want to do is transparent data encryption, which is going to encrypt everything. Everything in my database is encrypted. Now, performance is not a significant issue. We'll talk about that more when we talk about transparent data encryption. But that's going to allow me to encrypt the physical file in the event that it's stolen. When I use transparent data encryption, my backups are encrypted. My information in my log files is encrypted. My information in my temp DB is encrypted. Everything that's on the file system is encrypted, and it's automatically, that's where the transparent concept comes from, it's automatically decrypted anytime I read it. So the downside with transparent data encryption is anybody who has a valid user ID and password will see the data as if it were never encrypted. It's primarily for protecting the information while it's resident on the file system. And once again, the main reason for that, if your backup files are ever stolen, right, if your file system for your database is ever stolen, that information should not be easily read. And I say easily because any encryption, any lock can be broken, right? You have a choice of different levels of encryption to make it more or less difficult. There's always a trade-off with that, and the trade-off is performance. But we'll get into that in more detail. But for now, I just wanted to highlight the hierarchy, because as you read and do more research on SQL Server encryption, you're going to come across these various terms. So we want to talk a little bit more about those two paths, and I also want to talk to you a little bit more about asymmetric versus symmetric keys and certificates. So we're going to define those terms. So looking at some of those components in the encryption hierarchy, first of all, we talked about asymmetric keys. I want to say a few things about those. First of all, asymmetric keys are a pair of keys, actually. It says it's made up of a private key and a corresponding public key. Asymmetric keys are going to be a little more secure than your symmetric keys, but your performance with them will tend to be not quite as good. And that's a trade-off you're going to commonly encounter with encryption. The more secure the encryption, the greater the processing time, processing resources, and potential performance implications. So as it says here in my second bullet point, asymmetric encryption and decryption are relatively resource intensive, but they provide a higher level of security than symmetric encryption. Asymmetric encryption can be used to encrypt a symmetric key. So you can actually use these as one on top of the other. You have a symmetric key you're using, and then you can go back and use an asymmetric key to provide greater security on top of that. So you have a lot of different options, as we saw from the diagram, a lot of different paths to your encrypted data. Our symmetric key is only one key, and that single key is used for both the encryption process and the decryption process, as opposed to the asymmetric key. You had one for encrypting, one for decrypting. Encryption and decryption using asymmetric key is typically faster, as it says here, and is usually a really good option for most sensitive data. So you can get away with symmetric keys, and in some cases, which one you use is going to be determined by other choices. And we'll see that coming up, but I'll give you a little heads up. By going with transparent data encryption, you are also saying I'm going to use symmetric keys because that is what it's going to use for you. And then the concept of a certificate. A certificate is basically a way to identify who owns a key. The term it uses here, a public key certificate, usually just called a certificate, is simply a digitally signed statement that binds the value of a public key to who owns it, whether it be a person, a device, or a service that holds that private key. It's a way of saying whose key is this, and also a way of proving who signed, right, a document, who modified a document. Did you sign this document? Did you verify this document and then put your stamp of approval on it, yes or no? Certificates give us a way of verifying that you indeed signed digitally a document. That's a whole science we're not going to get into at this point, other than to say it's pretty cool stuff that makes it a little more difficult to forge a signature when it's digital than it does to forge a regular hand signature. And then third, we're not going to get into extensible key management at all in this video, but I do want to mention it because it's a significant portion of the security and the encryption available in SQL Server 2008. It allows you to manage part of your encryption hierarchy externally using special hardware, HSMs as they're called, hardware security modules. Really, really cool, powerful stuff. So once again, it gives you lots of different options depending on your needs. How secure do you need your data to be? And there's a rule or an adage I've come across: don't spend more money encrypting the data than the amount of money you would lose or the amount of money it would cost to replace the data. Right? You gotta weigh what you're investing, because you can make it you can make your data the most secure data ever imaginable, and then when somebody finally breaks in, it's nothing more than what Grandma Susie's pound cake recipe. Well, it might be extremely valuable to you, but it's not going to necessarily be worth tons and tons of resources. Looking at two options, we're going to focus on column encryption and transparent data encryption. Column encryption, two things to note here. There's a few other things we could point out, but I want to point out two key bullet points with each one. First of all, your applications are impacted when you go with column encryption because you have to include code that says, hey, encrypt this information. Otherwise, the physical information in the table is encrypted, as I showed you earlier when I showed you the credit card number and then I showed you the encrypted credit card number. If someone who has access to the table were to query the table, if you're using column encryption, the information they see would be encrypted. Secondly, I have on here no encryption delays for less sensitive data. Why is that? You're not encrypting the less sensitive data. So let's say in my customer table, I'm storing social security numbers or credit card numbers, and I choose to encrypt only those columns. The rest of the information isn't as necessarily as sensitive, so I may not have a problem with you seeing the person's name or their address or their phone number. So there's no problem with encrypting or decrypting that information every time I need to display it. With transparent data encryption, however, on the other hand, everything is encrypted. The second bullet point there, everything is encrypted. The tables, the databases, indexes, everything is encrypted. Your backups, your temporary database files, everything is encrypted. On the upside, your encryption is completely hidden from users and from your applications. When an application queries a table, SQL Server decrypts the information and hands the information to the application. So that means you don't need to change your applications to use transparent, hence the word transparent, right? Data encryption. Now the downside is once you break through SQL Server's security mechanism, however, once you have a valid user ID password to get in, you basically see all the information. It's no longer encrypted from your vantage point. So when does this come in handy? The primary time you're going to want to use transparent data encryption is when you're concerned about the physical storage media being compromised. You're backing up your data and saving the backups off-site, which is what you should be doing, right? I've seen stories, heard stories of people backing up everything and keeping it in the corner of the room where the actual servers are stored. Server room goes up in flames, everything's gone, right? So you definitely want your backups off site. Well, now you have the problem of possibly very sensitive information sitting somewhere in some storeroom, no longer protected by your security mechanism known as Windows and SQL Server, right? By using transparent data encryption, that information is encrypted on that file system. So two different options for two different business cases. So let's look a little more closely at SQL Server column encryption, which, once again, is called cell level in many of the Microsoft documents, column encryption in some of the other documents. Column encryption is implemented as a series of functions, built-in functions, and key management hierarchy, the hierarchy we were just looking at. It's a manual process that requires you to re-engineer or re-architect your application. Now, if you're doing the application, building an application from scratch, not a problem, plan ahead. And you can build in the functionality to use column encryption. Another thing to note, however, encrypted data has to be stored in a particular data type. It has to be stored in var binary. So, for example, if you're dealing with a date or integer information, if you want to be able to work with it as a data type or numeric information, you'll have to recast it back to that data type. One Benny, that's short for benefit, for column encryption is it's available in all SQL Server 2008 editions. So if you're dealing with Standard Edition versus Enterprise Edition, you can still use column level encryption. That's not true for transparent data encryption. That's only available if you're in a production environment. The only choice you have is the Enterprise Edition. There's another choice as well, but we'll get to that in a second. So what we're going to do now is we're going to encrypt some information in our Veronica's database. The information we want to encrypt isn't actually in the database yet. What we're going to encrypt will be credit card numbers. We've made a business decision. We want to keep credit card numbers for our previous clients in our database. When you do that, however, it's usually a very good idea, to say the least, to encrypt that information. So in this demo, we're going to modify our database structure to incorporate credit card numbers, populate that column with credit card numbers, fake credit card numbers in this case, of course, and then we're going to encrypt that information. So here, let's do that. So let's open up a new query window, and the first thing I need to do is create my database master key. And I'm going to put comments in this as I'm typing it just to help keep it all organized. Tell it what database to use, using the Veronica's database. And what I want to do in that database is create my, as I said before, database master key. And I simply say create master in blue because it's all keywords. Tell it what password to use. If simple works, go with it, right? So that'll give me that. Right click, execute, command completed successfully. So I've got my database master key. The next thing is to create my certificate. I want to make sure I'm using the Veronica's again, which I already am focused there, so I don't need to use Veronica's, but I want to say create certificate and name the certificate. I'm just going to call mine Veronica's 01. Set the subject for that certificate to be Veronica's. Only need to run that portion. Highlight, right click, execute. Got my certificate in place, and then the next thing is to let me make sure I'm commenting all of these just so you can help keep them straight. Create certificate. Third step, I want to create my symmetric key. Again, make sure you're using the Veronica's, and since I'm all in a row here, I can get away with not repeating that, but symmetric key, give it a name. Now I'm going to start using names specific to what field I want to encrypt. Credit card number. Now we don't have a credit card number in the database yet. We're going to take a little tangent out of this and create that, add that in, but here. That'll create a symmetric key called CC number underscore key underscore 1. Right? The name's not that important other than you want it to be able to direct you to what it actually means. with algorithm. Here's where I get to pick which type of algorithm to use. I'm going to go with the triple DES. We talked about those separately. Encryption by certificate. Veronica's, give it the name of the certificate I just created up above. Tell that to go. Right click again. Execute just that alone. And I probably typed something wrong. Veronica's has an I after the N and no I after the C. Try that again. You want to be consistent because now this name here has to match the certificate I just created up above. So when I typed it wrong, I get an error there. Alright, so I've done those three things. Now we need to take a little step back and make a few changes. We don't have any credit cards in here yet to encrypt. I've got a file out here I want you to run. New query, actually just go File, Open File. And if you move to the encryption folder under Course Files, right, so you're under C, Course Files, Encryption, there is a Update Veronica DB. We'll click that, and all it does is drop the customer table, recreate it with a new column, CC number, and then repopulate it using a local customer data file that now has another column with credit card numbers. So let's just run this. I got my 39,506 rows again. Let's check to see what damage was done. Refresh. My database is there. My tables are there. Right click on customers, pull the top 1,000 rows. That's all I need to see what I've done to this. And if I scroll to the right, there's my new column with my credit card numbers. None of these are real, hopefully. It's kind of randomly generated. Don't go try buying anything with those. Besides, no expiration dates, right? So I have that. I've got my credit card information. I have an extra window I don't need. Now, we're going to encrypt the data, but the way I want to do this, I want to have a before and after. So I'm going to add one more column to this table. And I'm going to copy the data and encrypt it in the new column. So I'll encrypt it during the copy process. So first of all, let's add a new column. Part 1. Just need to alter the table this time. Making sure it's big enough for that 128-bit long string that I'm going to generate as a result of the encryption. And here, put that there. So that'll create my new column. If I expand columns, there's my CC number column, my encrypted CC numbers, which is currently empty. I haven't put anything into it. But now the last step is I'm going to use that key to actually encrypt the data as I'm copying it over to the new column. First of all, I need to open the symmetric key, which we called CC number underscore key underscore 01. That was the key we created earlier, the symmetric key. Give it the certificate Veronica's for decryption. There's the key and the certificate that I created. So I've opened it. Now I can do an update, basic SQL update. The sales.customer table. And I want to set the new column I created, and here, just to make sure I did type that consistently, I'm not even going to bother trying to mimic all those letters. Just copy and paste it. Keep life simple, right? So set my encrypted CC numbers. That won't matter, but it looks better. Equal to, and here's where I get to put my wonderful encryption to use. Encrypt by key, it turns that wonderful shade of fuchsia, and if you haven't changed your default colors, that's what you'll get. Let you know you typed it right. use the key GUID function followed by my key, my cc underscore key underscore 01, and then the actual field that I'm copying. So I'm taking that field, passing it through all those functions to get it encrypted before I assign it to the other column. And I need to close out that symmetric key once I'm done. So let's break this up for readability. So that's pretty standard SQL. Update sales.customer, set some column equal to some new value. And I don't want to just copy CC number, but I want to pass CC number through my encryption by passing it as an argument to the encrypt by key function after it's been through the key GUID function. So here, let's run that. $39,506 rows affected. Let's see some data. If I right click on the customers, let's go back to top 1,000 rows again. Shrink that, scroll to the right, and I see my two new columns with my before and after. Pretty sweet. You can't see all of this one because it's a huge, ugly 128-bit encrypted value, which is exactly what you want. So now you're saying, okay, it's encrypted, but the unencrypted data is still sitting there on the table. You're right. You would want to delete this column, or a lot of different options. You could say give no rights or very, very restricted rights to the unencrypted data, however you want to handle that. So I could maybe produce a view that only gives access to all the columns except the CC number, so that when someone else is looking at this through a view. Now the problem is if the database is, the file system is completely compromised and they get a copy of your backup, right? They've got this unencrypted data. So you can just totally delete this column as well. You could drop this column. So different options. But there, I've encrypted my data by encrypting, in this case, just a single column using keys. So when you're implementing column or cell encryption, the things you're going to do are, first of all, create the database master key for your database, one for each database if you're applying this to multiple databases. If you go back to my initial diagram, we talked about a service master key also being required before you create your database master key. But that service master key is not a manual process. It's automatically created when you create a new instance of SQL Server. So it's already there. It's associated with the instance. Second, you want to create a certificate to protect your keys. Third, use that same certificate to create and then protect your symmetric key. Fourth, you'll need to alter your database to hold the encrypted data. What do I mean by that? You need a place to put it. You have to have the information stored in a var binary data type. That's what we did. We added a new column to our database that was of data type var binary, and then put the information in that location by, first of all, opening the key, encrypting the data, and then closing the key. So now that we've encrypted our information in our credit card column, we want to go back and decrypt it. One thing I want to re-emphasize, however, is that when you're encrypting and decrypting information at the column level or the cell level, which is another term you'll see in the Microsoft documentation, there is coding required for that. So the things we're doing here means those are the kinds of things you're going to have to do in your applications. Applications will have to change. But here, let's go ahead and do the decryption. So here I am on my SQL box, and I'm going to open up a file, which you can too. If you go to File, go to the Encryption folder under Course Files, and I have a column-encryption.sql file. Bring that in. Real simple piece of code for decrypting. Telling what database, tell it my symmetric key to use and the certificate to use, the things we created before. I have a function decrypt by key. I need to give it the column that I want to decrypt. And this is pretty standard SQL. I'm just giving the column a header or a title, telling it where I'm bringing it from. It's coming from the customers table. That's part of the sales schema. And then when I'm done, I close the symmetric key. One thing I didn't mention here, I say select convert varchar. That's because, remember we had to save this as a specific data type, var binary? And I mentioned that if you want to use it in, say, a mathematical calculation or treat it like a string, or if it's a date, you'll need to convert it back. So this portion of my select statement is just focused on converting this from a var binary, which is what it's going to come back as, to whatever data type I need it to ultimately be. So in this case, I'm converting it to a varchar. Now, if you need it to be something else, you're going to change that to whatever data type you need. But here, if I run this, voila! There is my decrypted information selected from my database. Transparent data encryption is actually a specialized case of using symmetric keys. So as I was saying earlier, when you're looking at symmetric keys versus asymmetric keys, by choosing transparent data encryption, which, be honest, is a lot closer to where I live, or I tend to think, okay, I need to encrypt the entire database because I'm concerned about files being stolen, or I need to encrypt particular columns because I'm concerned about people who have access to my database seeing data they shouldn't, right? Those are the business questions you need to ask yourself, and then using that, determine types of encryption to use. Once you've answered that, symmetric key versus asymmetric key, that's answered for you. Transparent data encryption, you're using a symmetric key. Transparent data encryption, also known as TDE, is going to encrypt your entire database using the symmetric key, which, by the way, your database encryption key is your symmetric key. They're actually one and the same in this case. The database encryption key is going to be protected by other keys or certificates, which are in turn protected by either the database master key, which is the option we're going to look at, or by using your hardware option, your EKM, where you can allow external sources and external hardware to manage part of your hierarchy. That's a branch we're not going to explore. We're going to explore the first branch using the database master key. TDE is only available in the Enterprise Edition, and as I hinted at earlier, there is one other option. You can use it in the Developer Edition, but if you remember the difference between Enterprise and Developer, I hope you do. Enterprise is a real version of SQL Server. Developer can only be used for development. You can never roll that out into production. So if you have a production environment and you want to use TDE, you're using the Enterprise Edition. Another cool thing about transparent data encryption, SQL Server actually can do some optimization on the queries when you're using transparent data encryption that aren't available when you're using cell level or column encryption. Remember, with transparent data encryption, everything, the entire database, everything is encrypted. So not only are your tables and your columns and the contents of them encrypted, but your indexes are encrypted. With that in mind, SQL Server is able to work within that encrypted world and produce better queries than it typically can on its own. I'm saying this is an automatic process, right? On its own. Another cool thing available to you with transparent data encryption is SQL Server will automatically do some optimizations on your queries. Now, SQL Server does that all the time, right? It's always optimizing your queries. There are some drawbacks to doing the column level, cell level encryption, where SQL can't do all the same optimizations because, frankly, the information isn't there. It can't do the same types of optimizations. With transparent data encryption, with the way it's implemented, not only is the data, the tables, etc. encrypted, the indexes are also encrypted. And as a result, SQL Server has a little different window into that data and can perform some automatic optimization. So basically, you get a little better performance. There's an article on MSDN, msdn.microsoft.com, called Understanding Transparent Data Encryption. If you need more information about transparent data encryption, I recommend that article. When we're looking at our hierarchy again, when we're talking about transparent data encryption, we're talking about, in our case, this path here. A DKM password, database master key, a certificate, and then a symmetric key leading into the encrypted data. Once again, the dotted line here at the bottom is another possible option when you're using TDE. We're not going to actually try this one today, but I do want to point that out as one of the two options. So here, let's jump over to my server and implement transparent data encryption. Alright, here let's open up a file. A file open. I already have the script typed up, so we're going to use that. I have an enable TDE DB encryption.sql. Enough TLAs in there for you. And here's what we have. Now, understanding encryption is probably a much bigger deal than actually turning it on, because you need to understand what you're turning on, you need to understand how to back it up and protect yourself, and you need to understand what to do if you need to restore. And we'll get to the restore part in another segment. But for now, just kind of run you through turning it on. I make some changes in the master database, and here I'll highlight all of those as a group. All this happens in the master, and that includes creating the master key, first of all. You want to use some strong password for that. That's probably not as strong as it should be, but you get the point, right? Next, you want to create a certificate for use in the encryption process. Once you've created this certificate, it's recommended you back that up almost immediately. Actually, if you don't back it up, when you go to turn on encryption down here, SQL Server will actually come back and say, hey, do you realize you didn't back up that certificate yet? Just in case it's lost your host, right? So it's kind enough to let you know before you shoot yourself in the foot. So just don't shoot yourself. But here, let's run through this. I'm going to do these two together. Use master, create my master key, create my certificate, hit run, and I get a couple of commands completed. So if I go to databases, system databases, go to master, go to security, go to certificates, and there's nothing there yet until I refresh. And there's my Veronica's misspelled. She's going to have to forgive me, right? But there's my certificate, so if I misspelled it, at least be consistent, right? There's my Veronica's, and I didn't spell it incorrectly consistently. So here, let's fix that. Since I botched it, I need to drop them in the reverse order that I created them. That's done. And actually, that's probably good enough. Recreate it. Just in case you make the same mistake I did, you know how to fix it. It's not case sensitive, it just looks nicer. There we go. Try that again. Refresh. And I've got my Veronica cert in there. And the important thing about that, like I said, you have to misspell it consistently at that point, and that just gets ugly. Because here, I'm going to back it up right after that, back up my certificate. And I'm just backing it up to the same file where I'm putting all my other course files. Obviously, that's not the place for a backup, right? You want to back that up to some separate physical medium, and maybe back up your backups, right? Lock it up with a padlock and put it in somebody's desk or something like that, okay? So I want to back that up. Once I do that, you should see those, where did I put it? In the course files folder. You should see those two files literally right there on my hard drive. Right, there they are with current date and time. So they are current. You want to put those someplace secure. Now that I've done all that background legwork, I can go ahead and encrypt my database. One more thing first. I have to create my database encryption key first. Here's where I get to pick which encryption algorithm that I'm going to use. I'm going to go with 128-bit encryption. I tell it to use the certificate that I typed above. This time I'm being consistent with the name. That's where it starts to matter. It looks like I typed it right that time. So I can go ahead and create that encryption key. You tell it to use the Veronica's database though. So right click that. Command completed successfully there. And then last but not least, all I need to do is set encryption on using the alter statement. And my database is in the process of being encrypted. I say in the process of because it does take a little while for that to finish. Here, we can check on the progress using this statement. If I simply select, I'm going to use a couple of built-in functions. One is dbName, and I'm going to pass to it the current database's database ID. Both of those I'm getting for free using some of my built-in functions and or variables. I want it to give me the encryption state. And where do I get it from? One of my system views, and it's actually the sys db underscore database underscore encryption underscore keys. So putting that in. Hit run. Alright, incorrect syntax. You know, it helps if you put a from with your select statement. There we go. So run that again. And I get a value of 3. Encryption state 3 means my database is completely encrypted. Now, my database was extremely small, as you know. I mean, 39,000 customer records is, that's nothing for SQL Server. So, in your case, you may find it takes hours in a production-sized database. So, you do want to plan accordingly for that. This isn't something you want to start at 2 o'clock in the afternoon on a Thursday, right? So, you do want to plan accordingly. So, this is something done after hours or on weekends to get your database encrypted. All right? So, with that, let's move on. So what were the steps to transparent data encryption? First of all, you create the master key encryption password. Now, this should be a strong password. Second, you create your certificate. As soon as you create that certificate, you want to back it up. Once again, as soon as you create that certificate, you do want to back it up. If you lose that, you lose the ability to decrypt your data. Third, you can go ahead and create the database encryption symmetric key. Once that's done, you can actually set encryption on by running the alter statement to turn on encryption. That will actually run the database through the encryption process. In our case, that completed in a matter of seconds, but I'm running with a relatively small sample database. In the production environment, that's going to typically take a lot longer. You can monitor the encryption process to see how it's coming, how far along you are. So looking at encryption algorithms, the science of creating algorithms to encrypt data is just that, a science, a mathematical discipline of itself. So we don't get into the details of where these algorithms come from or how they work. Just want to list them. There's basic data encryption, which is simply referred to as DES, and then there's a whole list of others that are all supported by SQL Server. What I do want to point out, though, about this list of 8 different algorithms is that you're generally going to see greater security as you go down the list, and some of those is probably somewhat intuitive. If you look at number 6, 7, and 8, 128-bit, 192, and then 256, right? You're getting a much longer string, so it's a whole lot more work to decrypt it. Also, if you're looking at 1 and 2, data encryption standard DES versus triple data encryption standard, right? You're increasing the amount of complexity and increasing the level of security. With that, however, comes a trade-off. As you move down that list, you could potentially see slower performance. So your performance is going to increase as you move up the list. But SQL Server gives you an option of all these types. Typically, if you're dealing with fairly sensitive data, business environment, going with number 2, triple DES, or any one of the last 3 on that list are some of the more common ones I've seen used. 128-bit, 192-bit, or 256-bit. So here, what are some of the terms you should know as a result of looking at this video? You should know what a symmetric key is, and it's simply a key that's used to both encrypt and decrypt information. It's not as secure as the next one on the list, asymmetric key, but it's typically less of a performance hit. Asymmetric keys are typically a pair, where you have a private key and a corresponding public key. Gives you a little bit better security, sometimes a little bit less performance. A certificate is what binds, it's kind of an identifier. It binds the value of your public key to who owns it, a person, a physical device, or a software service. And then we talked a little bit about extensible key management. We didn't go down that path, but I did want to introduce the concept and the term to you. And it basically allows part of your cryptographic key hierarchy to be managed outside by an external source. That in some cases may be an external hardware source. So what did we cover in this video? We talked about SQL Server 2008, its encryption hierarchy. symmetric and asymmetric keys, certificates, and then we looked at two primary types of encryption, column or cell, depending on what literature you're reading, and then transparent data encryption. And then last but not least, it's kind of ran through some of your encryption algorithms, not getting into a lot of detail on that. That's another topic in and of itself, but I do want you to at least understand how they fit in relation to each other. And with that, that brings us to the end of this video. Thank you so much for watching, and I look forward to seeing you in the next video.